After the thermoacoustic demonstration Stirling was such a great success, I immediately wanted to build a more powerful engine for much higher temperatures and pressures that was capable of producing useful energy. Over the last few weeks, I have been very busy making the parts for my new high-power thermoacoustic Stirling engine. Since the new engine is basically a scaled version of the old low-power Stirling, and I still don't understand enough of the theory, I'm very curious to see if it will start at all. The length and diameter of the feedback branch are only estimated for initial tests and still offer plenty of potential for optimization. The reactive power of inertance and compliance has a big influence on performance and efficiency, and I really need to look more into the theory and delta EC to get the best out of it. The cooling water circuit has only been designed for short test runs. I still need to install a better pump and a heatsink. I've built many powerful ring burners for my kinematic Stirling engines. I don't know yet if it is the best solution or if I should build another burner. I use a soldering torch for the first tests. Despite the provisional setup, the engine produces a strong acoustic wave that can be clearly heard and felt. The whole engine vibrates and makes a very powerful impression. With very little heat, I was also able to use the old power extraction unit where the piston oscillates very quickly. If the heater temperature is slightly higher, the piston jumps out of the cylinder immediately. Initial tests with a rubber band damper brought the engine to an immediate stop, presumably because it disturbs the resonance and the damper needs to be tuned to the frequency. Also, the possible stroke of the small piston is probably far too small, and I will have to build a cylinder with a larger diameter and stroke. The frequency with the piston installed at standstill and running is displayed on my test bench at 95.5 Hz. I still need to check this with an oscilloscope. Especially at higher frequencies, I don't want to blindly trust my simple measurement technique and self-written peak detection algorithm. My measurement evaluation always calculates the frequency, even if there is no oscillation. This probably leads to meaningless frequency data sometimes, and I still have to improve this. Overall, I'm very satisfied and surprised how good the results are with the first and very provisional and improvised setup. Now I have a lot to improve and experiment, and I hope that I will soon be able to produce energy with a thermoacoustic Stirling engine for the first time. As always, I would love to hear your opinions, help and criticism in the comments. Thanks for watching.